Hey guys, this is a standard operating procedure for the FAAS, Flame Atomic Absorption Spectrophotometer. So the first thing that you're going to want to do for this instrument is turn on the acetylene here. So this is the primary acetylene tank. It'll have an open and a close on here, and you're going to want to turn it towards open. You should just be able to turn it just a little bit to come on. After that, you're going to want to go above the instrument here and open this valve so that it's facing up like this, open. This is an oxygen valve that will pull out any extra acetylene that comes out. Then we'll come over here to the left side of the instrument, and we see these little dials here. We'll flip up this fuel switch, and the fuel bubble should rise to around 20, so that looks pretty good. If it's not where you want it to be, you can adjust the fuel flow using this knob here. Next, you'll need to turn your oxidant on. For this instrument, we always use air for the oxidant, so you'll turn this towards air. And you should see this silver bubble float to around 50. And again, if it's not where you want it to be, you can rotate this. Unfortunately, this awesome ignite button doesn't work anymore, so we're gonna have to use this guy to light the flame. So to light the flame, we're gonna open up this door right here, and you're gonna stick this long stem lighter directly in there and just physically light the flame like that. This is what a nice little blue flame should look like. You can then close this, and then we're gonna give a little demo on how to change the hollow cathode lamp. So changing the hollow cathode lamp in this instrument is actually the most delicate part of this operation because it's a quartz housing that's found in here. So whenever you handle this, you're going to want to put on a fresh pair of nitrile gloves and try to touch the glass part as little as possible. So the lamp is held in here by these two screws, but you don't need to mess with these at all. You can go ahead and leave these alone. What you want to do is first unplug this part of the lamp here, and then there's two springs back in here that hold the lamp in place, and these springs will snap back in place after you pull the lamp out. So if you're not careful, they'll snap in and they'll crack the quartz housing. So you want to try and hold these back with two fingers as you pull the lamp out. So you can just slide the lamp directly out, and you want to hold those springs in place until after you get all the way out, and then you can allow them to snap back in place. And the lamp is free. So then putting the lamp back in, or changing the lamp. So we're just gonna put an iron lamp in now, so it looks almost exactly like the other one. So what we wanna do is come in, move this out of the way, and slide it just back in like we normally did. There's another spring on the other side to make sure to get. It can be a little bit tricky to get it in there. Once it's in, you want to push it essentially all the way in and then pull it back about a couple of centimeters. Then you can plug this in. So this is a weird little proprietary plug, so you've got to match up these knobs exactly with these, and you don't want to force it whenever you go in there, because otherwise you'll push these plugs up into the instrument, and that'll damage the lamp. So you want to line them up, and it should just go in easily. There should be no forcing involved. So that's the lamp, and now you're ready to go. So after you put the hollow cathode lamp in, you're going to want to go to this chart that's taped right here on the top of the instrument that will tell you for what element you're using, what the wavelength needs to be at. So we're using iron, and it says it's 248. So you can use this coarse and fine adjust to rotate this to where you need it to be. Keep in mind that this is an old instrument, so these numbers are kind of hard to read, so you want to get close, and you can see that's a 248, so the wavelength is same. So now we're ready to actually begin taking samples, so we'll need to turn the hollow cathode lamp on. So the first thing we're going to do is make sure that all of these dials at the bottom here are turned all the way to the left. Then you can flip this master power switch on. So the first thing we'll do is set the lamp energy. So we'll set the signal dial to lamp, and then we'll use the lamp knob and rotate it until this reads the milliamp reading that's on the side of the lamp. So for this particular lamp we're using it's 10. So we'll set that to 10. And then in the real world, you'll want to let this warm up for about 20 minutes before you take any measurements. But for the sake of the video, we're just going to go ahead and move forward. So right now, we can take this and we can adjust the signal so that we get what reading mode we want. Absorbance is the most common and most useful. So we'll set it to absorbance, and we'll see that it begins to give us a value here that's fluctuating quite a bit. So this is kind of difficult to read this and to write down a value for this. So we're going to go ahead and set the mode from continuous measurement to hold. So now it will hold the measurement, and it will only read whenever you push the read button. And this red light tells you that it's reading. This value is going to change whenever you change out of lamp mode, and that's okay. It's still at 10 milliamps for the lamp So you can take your readings this way. So you can take this little tube here, is the sample tube that reads. And what you'll do is go ahead and take, so this is 1% nitric acid, so this is our blank. So this is what you'll do every time you take a reading. You'll put the sample tube into here. So whenever you have your straw drinking your blank, you can push this A0 button here so that it will take a reading and it will make that the 0 value. So sometimes it's better when you're using this instrument, rather than pushing this read and letting it take maybe a 1 second measurement, you want to get a higher average over that. So what you can do is press this AVE, and then you can push how many seconds you want to average for. So I'll do 5, and then push T to tell it that that's time. So now whenever it reads, this red light stays on for 5 seconds, and it will read for 5 seconds and then average all of that data. So you can get pretty good accuracy using this instead of just the 1 second. So now we're ready for instrument shutdown. So the first thing that you're probably going to want to do is turn off the fuel. So the way that we turn the fuel off is you begin by flipping down the big fuel switch, and then you can turn the oxidant from air to off, and that should have the flame off. It's important to go ahead and check though, just to make sure the flame is really off, and it is. So I want to go ahead and say that whenever you're operating with this instrument, you can turn the fuel off at any time to preserve acetylene, but you should try to keep the hollow cathode lamp on as long as you are taking samples. Because once you turn the HCl off, your calibration curve is no longer valid, which means that you want to keep this running as long as you still have experiments to run, because once it's off, your data is not necessarily valid, your calibration data. Additionally, always make sure to come over here to the acetylene tank and turn it to close, because otherwise we run the risk of just leaking acetylene out and wasting it, and that costs a lot of money. So to turn off this part of the instrument when you're totally done, you'll begin by turning all of the knobs to the left again, as they were at the beginning, and then flip the master power switch to off, and the instrument's off. And so now you're done. You can go ahead and close this to off as well. Thank you. Why is it blowing bubbles? A lighter directly in there and just physically